Hi, my name is Kenneth Earls, and today I'm going to be calculating the angular speed of a computer fan. The way I've decided to do this is I have a computer fan that I've broken a few of the blades off of. I've done this to make sure that there's enough time between lit and unlit portions to where there's a noticeable change on the oscilloscope. I have it in a box here, which I will put around the sensor to seal it from all other light except for my light source. And I have this hole right there. I have it all connected to this breadboard using this power source at 5 volts. I'm using this photoresistor here and this 5K ohm resistor to create a voltage divider between my signal wire and my power source. I have this connected to my oscilloscope, which I'll be using to measure the changes. Close the sensor in this box, and without the fan running, I expect that this signal should not fluctuate at all. Upon introducing light to it, I should see a fluctuation in signal as the photoresistor varies resistant upon change in light intensity. If I move it back and forth a couple times, signal should change right along with it. With the fan on, I'll now introduce light to the sensor, let it read on the oscilloscope, and then pause the readout in order to calculate frequency. Knowing that as light intensity decreases, our signal's voltage will increase, we can figure out the frequency of this fan by counting the number of peaks within a second. So if I have 5 blocks, each being 0.2 seconds, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. With a 9 Hz signal, I can calculate 540 RPM. This seems to make sense to me, because if you calculate a ratio of voltage to RPM based on its spec run speed versus what we were running it at, it comes out nearly the same if you factor in the fact that the fan is inevitably losing some speed based on its unbalancedness, because I broke a few off, so it tends to rattle and spin and hit the case of the fan itself. So I think this could be a close number if I can correctly assume that voltage is going to vary at a proportional rate with RPM through all the voltage range.